Okay, 1.4, perimeter and area in the coordinate plane. Starting off with some definitions, we have a polygon. It is a closed plane figure formed by three or more line segments called sides. Closed means closed, right? If it was just that like that, it has an opening here, right? Whereas this one here, you can't get in, right? It's closed. Plane means flat, that you could draw it on a piece of paper, right? Um, right. Whereas like a 3D shape, while you can draw it on a piece of paper, it's not really a perfect representation of that 3D shape. So a closed plane figure, figure meaning shape, formed by three or more line segments called sides. On the right here, we have a little table, number of sides, and then the type of polygon. These are good words to know. We have a triangle, a quadrilateral with four sides, a pentagon is five, a hexagon is six, heptagon is seven, octagon is eight, right? Eight, stop sign, octagon. Decagon is 10, a dodecagon is 12 sides, and then for anything else that's not on this list, we call it an n-gon. Like a 13-sided figure would be a 13-gon. If you're on a test or something, some kind of assignment, and you don't know what the word is, but you know there was a word, like say you forget the word triangle, right? I don't think we're going to, but say you did, and you're on a test and you're supposed to label a triangle as a triangle, and you can't remember it. If you say three-gon, um, three, gone, you will get more credit than if you got it wrong or if you just didn't list anything. Okay, so if you know that it's a four-sided, a five-sided figure, whatever it is, but you can't remember the specific word, just list it as like a five-gon or a six-gon, right? Even though there's words for that, if you can't remember the word, then fall back on just calling it a gon. Convex versus concave. A convex polygon is a polygon that if you were to extend all of its sides, then it wouldn't cut anything off. A concave polygon, you could extend a side, right? This side right here is extended, and it cuts it in parts there, right? So a concave polygon cuts itself whenever the sides are extended. All right, let's scroll down. Number one, we're going to classify each by their number of sides, and then also by convex or concave. We'll do part A for both of these first. This one has 1, 2, 3, 4, so it's called a quadrilateral. The bottom one has 1, 2, 3, 4, 5, 6. Six-sided figure is a hexagon. Now, for convex versus concave. I think of most shapes as being convex in general, and then if I'm able to cut it in half or cut it in pieces, then I call it concave. Number one here, or the first one here, if I took this side and I extended it, it would cut it. So this one's going to be concave. For the second one here, I could extend all of these sides and I wouldn't be able to cut any pieces of it, so it's going to be convex. All right. Perimeter and area. Hopefully remember these words, but perimeter is the distance around the object. Area, there's other ways to say it, but it's the size inside. It's how large of a footprint it has, right? Perimeter would be measured in plain old units, whereas area is units squared. Now we have some special shapes that we want to look at. We have a triangle, a rectangle, a square, and then a parallelogram. A triangle, hopefully we all know a triangle. Whenever we find the perimeter, we just measure how long each side is. For its area, we need the height and the base, and the area is 1/2 base times height. Now I want to go down to the parallelogram. A parallelogram has opposite sides parallel. That's what those extra arrows mean on there. It is base times height. And a lot of the time, the height will have a dotted line on it. So area is just plain old base times height. A rectangle and a square are both parallelograms. So it makes sense that their formula for area would be the same as the parallelogram formula. Both base times height, we have base and height. Base and height. All right, let's look at number 2. Find the perimeter of triangle PQR with vertices P, Q, and R listed there. Sometimes these are a lot easier if you go ahead and graph them. So that's what I'm going to go ahead and do. P is at -1, 4, 1, 2, 3, 4. Q is at 2, 4, 1, 2, 3, 4. And then R is at 2, -2. So we're finding the perimeter of this triangle. Now, if we're able to, we want to just count over to see how wide some of these sides are. From R to Q, I can go 1, 2, 3, 4, 5, 6. This is 6 units long. From P to Q, I can go 1, 2, 3. Now that long side there, we're going to call it PR. I need to use the distance formula to find out how long that is. We could use the Pythagorean theorem, but since we've been using distance formula, that's what I'm going to use. So I'm going to have my big square root, parenthesis, parenthesis squared, parenthesis, parenthesis squared. And I'm going to grab my points from P. Those are -1, 4, -1, 4. Then I'm going to put my pluses in there, minuses. And then I'm going to look at my point R, which is at 2, -2. So simplifying this, I have -1 minus 2 is going to be -3 squared, plus 4 minus -2 is actually going to be +6 squared. So this is 9 plus 36, so square root of 45. "45 does not have a nice square root, so I'm going to need to break it apart. It breaks apart into 9 and 5. 9 breaks apart into 3 and 3. So I have a pair of 3's and a single 5. The pair comes outside of the root, and the single stays underneath. So this side over here is 3 root 5. So my perimeter is going to be P equals 3 plus 6 plus 3 root 5. And then to simplify that, I'm going to say P equals 9 plus 3 root 5. And that's it. If I were to find the area, I know it doesn't list it here, but I'm going to do that anyway. If I were to find the area of this triangle, I need to find the right angle. There's going to be a right angle at Q, right? Because one of those is horizontal and one of them is vertical. And area would be 1/2 base times height, 3 times 6. So that would be 1/2 times 3 times 6. 1/2 times 6 is 2 times 3 is 6. I know it doesn't say the area, but I know that that could be useful on homework. Scrolling down on number 3. Again, we want to graph this and use that if possible. So A is at 1, 3, 1, 2, 3. B is at 3, negative 3. C is at negative 2, negative 3. And D is at negative 4, 1, 2, 3, 4, positive 3. All right, so this is our parallelogram. My base is going to be on the bottom here. I'm going to count over 1, 2, 3, 4, 5. 5. For my height, I'm going to need to draw that in. Whenever I count it, I'm going to be 1, 2, 3, 4, 5, 6. So area is base times height, 5 times 6, which is 30. If we were to find the perimeter, we would need to count over. We've already done that for the 5, for the bottom side here. We'd have to do that for the top side, and then we'd also have to find DC and AB, kind of the slanted sides on the sides, on the left and the right side of it. I'm not going to do that, but that is how you would do that on the homework. So again, on the homework, whenever it gives you a bunch of points, try to graph them first. See if that can show some of it a lot faster. Because had we not graphed this, or had we not graphed this one up here, we would have had to do a distance formula for each side. We wouldn't have had to, like for this one specifically, PQ, that top side, we would have had to use the distance formula for. QR, again, we would have needed to use the distance formula. So it's good to graph them and look at them that way. All right, that's all. Good luck on your homework.